An easier section, or this is a really nice section to start proofs on, because we're gonna do this with algebra problems. So on page 136, these are properties of addition and subtraction that you've done for several years. But now we're gonna actually use them in our process. So the addition, subtraction, multiplication, and division properties, that's simply just saying, when I solve an equation, right? To get my variable all by itself, whatever I do to one side of the equation, I have to do the other side of the equation. That inverse operation, that's what those four things are saying. Okay, so if I would have, for instance, x minus 6 equals 7, I would add 6 to both sides. So the reason why that I can do that is the addition property. Okay, so this is nice to kind of ease you into doing some of these proofs, because you're familiar with algebra problems. Okay? If you look at the other things, what's the difference between the reflexive property and the symmetric property? This is really kind of key to geometry. The reflexive property is what? How could you describe that? 4 equals 4. So it's the exact same thing equal to itself. Looking at yourself in the mirror. Right? That's the reflexive property. What's the symmetric property? The symmetric property, and I know you're going to say, well, this is dumb, but the symmetric property is saying, if I had 7 equals x, the symmetric property is just flip-flopping it and writing x equals 7. Okay, so it's the exact same thing, it's just the order matters. That's basically what the symmetric property is. So in a couple of the first early proofs that you'll do by yourself, this will be one of the last steps. If you are asked to, in your original problem, if the proof statement is x equals 7, and when you did your math throughout the whole problem, you got 7 equals x, your last step is to rewrite it in the correct order. So I know that's kind of being really picky again, but again, if they tell you that the proof is this honestly isn't the same thing. It is, but they just want you to recognize that it should be written in that order. So that's the last step. Okay, so that is what the symmetric property is. Transitive property we've talked a lot about. It's the same as the law of the syllogism, right? But that one goes back to, if A equals B and B equals C, what do? We pluck out the B's, and what's left over? A equals C. And again, we use the transitive property a lot. We already did that in our first two, right? In the 2 paragraph proofs that we did for today. Okay? Substitution. Honestly, you could use substitution just about every single problem. So when you're doing the problem that we had up here earlier of x minus 6 is equal to 7, or whatever I had up there, and we said that we're going to add 6 and add 6, and my answer would be x equals 13, you could really honestly say this is the substitution property, because I substituted 13 in for my previous answer. But again, I would be specific, and I would actually call this the addition property instead. Okay? So in a sense, what I'm saying is substitution can kind of be used a lot. But I would try to be as specific as I possibly can. And then the last one is the distributive property. And so anytime that I have parentheses in a problem and I actually do distribution, I can use that. But if you would say multiplication for the distributive property, we would live with it. Okay? We don't want any. You want this? No. All right. So any questions with those properties? So if you look up here at the board, if 3x is equal to 120 And then the next thing that they would give me is x equals 40. What did I do to 3x equals 20 to get to x equals 40? I divided. So what property did I use? I used the division property. Okay? If 12 equals AB, and then they say AB is equal to 12, all I did was flip-flop them, right? Anytime that I flip-flop them, it's my symmetric property. If AB equals BC and BC equals CD, so again, notice when I have four things, but the two middles are the same, I'm going to pluck those out, and then I get the first is equal to the last, so that's my transitive property. If y equals 75 and y equals m, or the measure of angle A. Here's something that's really important also. Remember, this right here, when I write something like this, y equals the measure of angle A, that's just saying that it's a degree measure. So instead of saying 75 degrees, which I should add a degree symbol by the 75, I can write the measure of angle A, and that means the same thing. So basically, I'm substituting one for the other, and this is kind of confusing because it's on two lines. But if we put them on the same thing, the measure of angle A is equal to 75, so basically I substituted the measure of angle A in for y, because y was that. And so then we say that the measure of angle A is 75. And when I write it this way, again, I don't need my little degree symbol if I use the little m out in front of the angle. Okay. Last one, if 2x is equal to 3, how do I get x equals 3 halves? What would you say we did to that problem right there? We did what? We divided. We divided. Exactly right. So my property would be the division property. If xy minus ab equals wz minus ab, how can we say xy is equal to wz? What did I do to the problem on both sides of the equation? Okay, or I subtracted AB, right? So how would I get to xy equals wz? Some people kind of get trapped in this one and say this is probably transitive property too, but basically I'm just subtracting AB on both sides. So it's like saying in my problem up there, I added 6 to both sides. Now I'm subtracting. So I would say that this would have been subtraction. All right. So let's try to do this. If I had a problem like this, and they said given, and they said my proof. So again, every single problem from here on out that is either in the book or on my quiz or the test should give you something like this. And then they're going to tell you that the given is x over 3 plus 4 is equal 1. And the proof is x equals negative 13 fourths. All right, so this is what's going to be given to you. And they're going to tell you to use a proof or a 2-column proof. So again, a 2-column proof is just simply this. I'm going to have a statement. So again, I'm going to come up with something. Always start out with what? What did we tell was a good proof?
Given.
The given. And why can I say the given? Because it's given, right? So that's it. So again, my first statement is always the given from my problem. And then I always need a reason why. So basically, I'm going to draw this chart every single time that I do a proof from here on out. Now again, if you like the paragraph proofs, you can do the paragraph proofs that we just did the other day. But I'm going to tell you it's probably a little simpler this way. Okay? So I have to come up with some kind of statement, and then I have to have a reason that I can say that. What are my possibilities of the reasons? What did we talk about yesterday? I could use what as a reason? Okay, we could use given. What else? Definitions. Postulates, right? We talked about a bunch of postulates. What did we introduce at the beginning here? properties. And what was the T one? Theorems, right? What's a postulate? Why is a postulate a postulate? It's something that is just what? It's true, right? It's kind of like a rule or a law. What's a theorem? That's that really smart guy in the bottom of the building by himself, right? Doing math. So a theorem is proved by some smart person. Okay, that's the difference between theorems and postulates. All right, so I need a statement. I need a reason why. Every single time. So like for this one right here, if we would say that this is 1, 2, 3, 4 steps, I don't know what it is. I would tell you that this is 4 steps at the beginning. Okay? And obviously, I always know what my first step is. What's my first step? A given. So I would write it out. X over 3 plus 4 is equal to 1. And why can I do that again? Because it's given. So as Cora just told me, she didn't do this on her paragraph proof, so I should throw my marker at her, right? But do not forget this. Easy point, right? You always get it. Now realize, each one of these, so this proof right here would be worth 4 points. Each step is worth 1 point. You get a half for the statement and a half for a given. So even if you don't understand this and you're struggling with proofs on the quiz and the test, just try. You're going to get 1.5 points every single time, right? Because the given is always given to you. And the prove, this should be your last step. You just have to come up with the reason why. So you always get 1.5 points on every single proof on the quiz and the test and the homework. Okay? And again, as I write the numbers up on the board for that day, there'll be little numbers like this. So if this is a proof, this one would have been worth 3 points. But I'll tell you that every single day. Okay? And that seems to help a lot. All right, so mathematically now, or algebraically, what's the first step to solving this? Subtract 4, right? So this is where algebraic proofs kind of get confusing because of when do they actually do the problem and when do they actually write the next step. Okay, so from getting from step 1 to step 2, I'm going to do my subtraction, and what would be left over? X over 3 equals negative 3. Everybody agree? Okay, so what is my reason why? What did you do? Subtraction property. I don't think my proof should be right, is it? No. I got 2 different ones up there. Sorry, so this should be. I believe there's only one more step, right? Sorry, I was looking at 2 different problems. So now, what's my last step? How would I solve? I'm going to multiply by 3 on both sides. So again, if I do my math, I get x equals negative 9. And so again, my proof is x equals negative 9. So once you write down your proof, you know that you're done. But I got to come up with the reason why. What did I do? Multiplication property. And guess what? That's your first proof. That's it. That's all you got to do. Not that bad, right? Okay. Once again, as I write down here in big letters, don't get frustrated through working on proofs. At the beginning, your biggest question is going to be, well, I don't get where to go. I don't get what that first step should be. And again, I know we've talked about this, but here, let's talk about it again. The process we want to go through for a 2-column proof. Number 1, state the theorem to be proved. So we want to state that. Okay? Show the given information. Again, some givens will have multiple parts. Meaning they might tell you 3 or 4 different things. You cannot argue the given. Even if you don't necessarily truly believe in it, you cannot argue the given. Whatever is given is fact. And that's where some of, again, figures in the book might not really look like what they say in the given. Meaning they might say that the angle is 85 degrees. Well, 85 degrees should almost be 90 degrees, right? Straight up and down. Theirs might look like this. But if they tell you it's 85 degrees, you got to say that that's true. Okay? Draw a figure. Again, we saw some of this yesterday, right? If you can draw a figure and show yourself, it's going to help out. And then in the given, if they don't already do it for you, put your little slashes, put your little arcs. Draw things on it. Show yourself exactly what they give you. All right? And then state what is given and each step by using deductive reasoning. So we're just going through the process and trying to figure out what my steps are. Remember that you should always use true statements. So this is what we just went through. Again, all those 5 things that you can possibly use. Make sure that you always use those. Okay? And be as specific as you possibly can. Again, remember we're talking to the most, I don't want to say it, but dumbest people in the world about math. So even though you understand it and you think it's really obvious, still got to tell everybody. Okay? So let's stop right there. We'll come back on